I'm Tommaso Teofili from Sourcesense, and I'm going to talk to you about how to implement natural language search in Solr. One possible approach. So roughly, this is the agenda. So highlighting briefly what is the idea, the approach used to implement such a functionality. And then we'll dive into more technical details, seeing all the components that are involved there, and discuss a little bit the results. So just before we start, some background about myself. I'm a software engineer at Sourcesense, mainly focused on the enterprise search domain. And also I'm a member of the Apache Software Foundation, and I'm contributing to some projects. And OK, just before we start, some history. So this is Google in '99. I was 19, and it was kind of scary if you compare it to the current one, the current version of Google. But the point here is that what was the search experience at those times? More or less, you had to do lots of queries in order to get the results you were looking for. So, and another thing is that you had to kind of guess what keywords were written inside the documents you were looking for. So you made keyword-based search. And this is how it looks like today. Just differences. We can see a lot. And talking from a Lucene Solr point of view, we have some of these functionalities are already implemented, like pasting, spell checking, suggest, and so on. But what I'd like to highlight is some smarter functionalities. This one about the first result. So the result from the Google Finance website. And the cool thing here is that we can see that this result is presented in some particular way. And we can guess that what is being done under the hood is that Google knows, the search engine knows, that this is kind of typed result. This is a financial item, OK? We can say like this. But another cool thing is that Google is understanding what we are typing in the search box in some ways. Yes, you know, we have the PageRank algorithm, and lots of things play a role in the scoring of documents. But here, we see that we typed a natural language query, books about science, and the three keywords appear only in the fourth result. And this is something that could be could lead us to think that Google is doing some kind of understanding and, for example, giving boosts depend of the words, of the term that we are typing in the search box, OK? So the about term, for example, could have a lower boost when doing the query. And if you take a look at one of the Google papers and other pages on their blog, is what they're actually doing. They're using techniques to understand the queries and the documents they ingest in order to provide better, improved recall and precision. So this is also our challenge today. Improved recall and precision, and being able to match concept more than keywords, OK? So article about science, and our 3 words articles about science could even don't appear in our documents. And also differentiate between movies by Kevin Spacey and movies with Kevin Spacey. You know, Kevin Spacey plays different roles depending on the movie. And this is, would result in easier experience for non-expert users. Since, you know, my grandmother, my mother, my father are not so technical. So apart from that, each of us gets more cool results if it doesn't have to spend time thinking about the query he has to write. So, and this also applies both to horizontal domains, like we saw Google, but also to vertical domains, some more focused domain. We have some hurdles, some issues. That the main one is understanding documents that we get indexed, talking Lucene Solr jargon, and the user queries. And in order to do that, we had to extract domain-specific or domain-wide and differentiate between those ones, entities and concepts, okay? And obviously, one cool thing that we should always keep in mind is performance, since, okay, we have smarter functionalities, but if it takes 10 seconds, we have lost our users. So, going through a use case about a sample movies magazine and our Solr-based search engine. So, the most difficult part is the tweaking of the natural language part. And we are going to expect improved recall and precision, and those more time and clicks on the site that takes us money. This is an example of an article taken from Rotten Tomatoes about one of my favorite movies, Back to the Future. And here you can easily guess that these colors have some meaning. So the green ones, the green highlighted words represent persons. The blue ones represent roles, while the red ones, magenta ones, represent movies. And this is our goal in order to leverage these functionalities of natural language search. So the approach is using natural language processing techniques, and both processing documents at indexing time and processing queries at search time. So when our documents reach the index, we analyze the documents and extract something and write that something in dedicated fields, and use some Lucene level functionalities, types, payloads, and so on, in order to prepare the smart functionalities on query time. While at query time, we use that kind of information and the analysis we've done on the query to leverage the concept matching. And also, we can do boost depending on the type of words, in-sentence search, and we'll see later. So briefly, NLP is an AI discipline. And how much of you know more or less what is NLP? Okay. And so it's roughly analyzed at various levels text. And you can think of a pipeline, okay? So there is processing of our text, and at each step of the pipeline, the text gets enriched in some way, okay? So you can think of tokenization, sentence detection, chunk detection, entities extractions, and this kind of incremental enriching of stuff. And then, at the end of the pipeline, we have extracted concept and named entities. So, from a technical point of view, the choice was to use an Apache project called UIMA to plug the NLP algorithms. While at indexing time, we use dedicated update request processor that is already committed to the Solr code base since Solr 3.1. And also some custom tokenizers and filters, and a custom query parser plugin. So why we chose Apache UIMA? The main reasons are two. One is that it's a standard, and because of natural language processing is something that has some academic background and university apply to such a field, it's important for us. And also because we have the components for extracting things. And also it has scaling capabilities. So as I was saying, we don't want to let the user wait too much. And this is a common UIMA pipeline. And the things to note is that we have each block is called an analysis engine, and that the enrichments are stored in an object called common analysis structure that gets annotations over the text we processed. OK, but we said UIMA is a standard architecture. It stands for Unstructured Information Management Architecture. So we have to plug the NLP algorithms via some other components, or also the UIMA DONS package, which leverages some basic functionalities. OK, so here is a rough classification of some of the open source alternatives to implement NLP algorithms. And Apache OpenNLP, Apache Mahout, Apache Stumble, and also there is the Stanford NLP that is from Stanford University, obviously. And these kind of tasks are common in NLP. Sentence splitting, so inferring what are the sentence segment inside the document. Part of speech tagging, that is attaching a label to a span of text and saying that is, for example, it is a noun, a verb, an adverb, or something like this. Chunking and parsing, that is giving structure to a sentence. So getting out some kind of tree structure of a sentence. Name entity recognition, that is the goal of extracting movies, actors, and so on. And also some clustering and classifying stuff done, for example, with Mahout. OK, this is our basic architecture. So at a query level, we have a query like Presidents of the USA. While at indexing time, we have our UIMA update request processor, UIMA tokenizers, and filters who process the documents being indexed. And for now, we have a link-free UIMA pipeline. We'll see what are the possible architectures of the UIMA pipeline. OK, so this is the idea of the UIMA update request processor. So a Solr, an XML head from Solr reaches Solr, and then when it hits the UIMA processor, we configured some fields to be the text from some fields to be extracted and passed to the UIMA pipeline, and also we have configured that we only want some kind of extracted named entities, and in the UIMA Jergo, only some kind of annotation. In the example here, we have chosen that the movie annotations have to be written in the movie Solr field. So our UIMA pipeline analyzes our text, American Beauty is a movie, something, extracts that American Beauty is a movie, and writes in the American Beauty text inside movie Solr field. OK? And we are going to see some reviews about movies, Truman Show, Back to the Future, Stranger Than Fiction, and so on. OK? And as you can see, they're only title and text. OK? With a simple bash script that is impossible to read, we are sending the documents to Solr. And in a very short time, we can start seeing from the log that some kind of things have been mapped to some fields by the UIMA to Solr mapper. But we are going to read it from here. OK? So we have give us all the documents inside our index. And we have the 10 documents we have ingested. And for example, we can already see that some persons have been extracted, OK, for the first movie we did, one that is Back to the Future, OK? So, and this is done via the Apache OpenNLP components, okay? There are, as I said, many alternatives, but this is one, okay? Now we want to take these kind of things to the Lucene level. Why we want to do such a thing? Because, first of all, we saw that we are passing to the UIMA all the document, okay? So all the fields inside the documents are passed to the UIMA, but okay, we can choose which fields to process and which not, okay? But if we want to have specific pipelines to extract specific concept and named entities with a good performance, it's not a good idea to put a tremendous pipeline with all the NLP algorithms to process all the text, all the fields inside. So working at a fine-grained way, we can put inside our schema XML file some tokenizers and filters that are per field, that are working per field and calling only specific pipelines for that type of text. Okay, so we are talking about, and the second reason is that with the Lucene level, we can play with types and payloads that are something that can be very useful when searching. So roughly, a type is something that denotes lexical feature of a token, okay? And the payload is just a byte array that is stored at each turn position. So you can write whatever you want in the payload, in the byte array. But we can choose to write things we can use at search time, like some feature extracted by our NLP algorithms, and then make smart queries using such payloads, okay? This is the idea for a UIMA type-aware tokenizer. So we have only the text, so since we are at a field level, okay? In Back to the Future, Marty McFly is interpreted by Michael J. Fox. This is, again, passed to a UIMA pipeline, and some kind of annotation is extracted, and the text is decorated with this character annotation for Marty McFly. And also, it says that it has role protagonist, okay? And here, in the UIMA type-aware tokenizer, we said, I only want to write in my Lucene Solr field the span of text which are covered by character annotations, okay? And also, I'm saying to this tokenizer that I want to store the role in the type, in the term type. And one thing that one can do is writing a simple map of relevancy for roles. So, for example, protagonist has three in relevance, while common actor has 1 in relevancy. And use this kind of payloads and write this thing in the payloads, and then use it in a custom similarity plugin. So when use the roles of the actors as custom similarities metrics. Okay. This is kind of, we can do tricky things. We can do depending on our domain and our needs, we can do a lot of things. So now we are at the query parser level, at the search level. And what we are able to do? Again, passing things to our UIMA pipeline, which execute NLP algorithms, we can analyze user query and extract and query on specific fields for concepts and entities. Okay, and give higher boosts to concepts and entities because more or less it's about true that the word about has a lower boost than a word like representing an actor, okay, for finding the documents, okay? And again, like I was saying previously, we store types and payloads and use this kind of features at query level, and boosting terms and doing synonym expansion on the basis of the part of speech or the types, for example, the roles which we have written for actors at query time. And this is something that if you go on the web and look for Google doing these kind of things of natural language processing, doing in queries, that's a good part of their work. Since the smart synonym expansion, they said, improved so much their recall and precision. So it's something that we can trust, okay? Google has a nice use case. Okay, and again, since we can extract sentences at the document level, we can search within sentences. And yes, you said, so what? But the idea is that if I search for 2 keywords, okay, the probability that the 2 keywords are more relevant if they appear in the same sentence is much higher than if the keywords don't appear in different sentences, okay? And yes, you know, in Lucene Solr we can do proximity search, but no one is granting us that the proximity search is aware of sentences, okay? And again, another cool thing is using entities for doing faceting and clustering. This morning, I've also been to the Mahout talk, and someone was concerned about the performances of the clustering. And think of using these entities for doing clustering. It would be much more easier from a computational point of view, since you don't have to ingest all the document. Okay, you already have some tags, some points in the vector space model, and you can more easily and with a better performance extract the clusters. Also, if we have a UIMA pipeline which contains an algorithms which can recognize locations, like, for example, OpenNLP, Apache OpenNLP can do, we can use these functionalities and identify locations in order to use these locations with Solr spatial query and do filtering and boosting. This is something it would be very good. So I'm just showing now a simple 2 or 3 queries just to highlight the improved precision, okay, compared to the Dismax query handler. So again, here is Back to the Future. That is not a natural language search, a natural language query. But with the Dismax, we have score of 0.39, then 0.13, and then 0.04, okay? If I do this kind of thing with our natural language search query parser, I have improved my score because I was looking for Back to the Future, okay? And yes, okay, also Dismax found Back to the Future as the first result, but the score is different. And more to say is that the second result has much lower score. And this is something that tells us that, okay, I've implemented my natural language search query parser plugin has to be lenient and allow to find also documents that are not perfect match, but give a very higher boost to the very relevant documents and give a low boost to the not relevant. So we have 0.03, 0.01. Okay. And here is a query for Nicole Kidman films, and I got Moulin Rouge. Okay. Again, with natural language query parser, I have improved my score. And if you look at the debug query, the cool thing is that it extracted that Nicole Kidman is a person, and it looked into the person underscore SM field, okay? And it gave higher boost to that kind of matching. And you know, I've played a little bit on the expansion policy here. And it was quite of R&D and tweaking for the single use case. But this makes the job quite well. Same thing here, being John Malkovich. So movies with people called John Malkovich, with this max, and here with the natural language search. And look what's happened. Being John Malkovich, you know, has 0.24, but adaptation, which is with John Malkovich, has 0.20, while with the other one, it has a lower score. So we have seen that the score has been improved in terms of relevant documents. So the precision is more accurate. Okay. Speaking from on the second issue we had is that performances. The Solr UIMA update request processor that is committed to Solr uses the UIMA as in-memory in its in-memory implementation, and I've seen that this doesn't scale. Okay, since you know, when you have to when you use it on the indexing phase, then you know, if you don't have near real-time search, that is not a big concern, or it may not be a big concern. But when you have to use it at query time, then you have an issue, since you can't let the user wait. So what I've been using is an add-on for UIMA called UIMA AS, asynchronous scale-out, which allows to deploy UIMA pipelines with asynchronous architecture based on JMS and Apache ActiveMQ. And you know, we have, if you ever heard about IBM Watson, that kind of system is using UIMA AS to do real-time answering to questions made to the quizzes in the US. So, and with the IBM Watson Bison, the human in this kind of quizzes, with responding even earlier than the human. And they use this kind of architecture. Okay, so the client make request, and there is a synchronous middleware based on Apache ActiveMQ. And the UIMA AS service instance, there are, they can be deployed both as remote services or as local services. But even here, within a laptop, the performance boost is tremendous. So again, talking about performance, the basic in-memory UIMA implementation of our NLP pipeline is lower with NRT indexing, but with search, we can't make it. There is also another component in the UIMA ecosystem called the Simple Server, which implements a REST interface to call a UIMA service. But again, it's faster, but need to explicitly digest results. It doesn't scale horizontally so well. While with the UIMA AS, we have fast pipelines with NRT indexing, fast search, and scales nicely with lots of data. So this is a rough comparison using Solr meter. And here you can say in the upper histogram, this max with 10 queries per second to my local laptop. And with the same configuration using the natural language search query parser. And, we have comparable results. And, again, we have these boost functionalities, smart functionalities. We have here some longer queries, but if it would cost maybe just another node or just a remote server to have the plain same performances. Okay, so here is a wrap up to what we've seen here. We have a general purpose architecture, and this is good since we can plug whatever we want. We can develop our NLP pipelines and plug them into this architecture and change the things flawlessly without having to code something inside Solr. Generally improved recall and precision, but here we have to highlight one thing. NLP algorithms accuracy make the difference, since we can't say that everything borrowed from each NLP algorithm is okay and can extract the entities and the concepts we want for our domain. Okay, so here again is a matter of you have to see your domain, your requirements, and so on. So there are lots of open source alternatives. You have to choose the right one, spend some time developing your NLP algorithms or putting together your pipelines, your building blocks. But after that, you're okay, since you have lots of alternatives. And as I've seen here, as you've seen, we have good performances even with these costly operations, So from a technical point of view, the Solr UIMA is committed to trunk. There is some rough code of this demo, of the tools for this demo on GitHub, but not the final version, so don't download it today, since I'll commit it in a short time. And here is an interesting link about what I was saying before about Google using natural language processing, and the wiki page for the Solr UIMA at Solr. And that's it for me.